by in just a second. I'll kind of show you where we'll use this in the future. So we're going to be dividing polynomials, and honestly it's just going to be a memorization of a process. It's actually really easy because you do the same thing every time. So long division is one of the many methods you can use to divide whole numbers. Like back in the day, we learned back in, I don't know what grade, but younger years, we learned how to divide things by hand, and we did long division with numerical long division. Polynomial long division is going to work in the same fashion, and we'll talk about that in a second. We're going to review it and go over it and learn it. So just some vocabulary words. So whatever we're dividing underneath here, this is what's being divided. So this is this, 672 divided by 21. Then this is called the divisor, because that's what we're dividing by. And then this is the quotient, what we get when we divide. What I want you to notice, even if you don't know how to divide it, I went through and divided this out and we get 0. That means there's a remainder of 0. So that means it divided perfectly. Does that make sense, everybody? Since there was nothing remaining, it divided perfectly. So we know for a fact that 21 times 32 equals 672. Does that make sense, everyone? Okay, so we're going to do the same steps for polynomial on long division. We go through, we're going to learn it in just a second. Now look, if I get a remainder of 0, then we know for a fact that this times this equals this. Awesome. Now look why that might be useful. If I said to you, is negative 1/2 a solution? So if this is a factor, this is a solution, right? If we get a remainder of 0, then this is a factor, therefore this is a solution. That's where we're going to use it in the future. Awesome. Okay, so just a reminder of how this works. Like long division, we're doing something really basic to show you how it works. So I go off to the side and I make a little bulletin point. So we're going to do 7 divided by 2 evenly how many times? 3. Now yeah, there's going to be a remainder, so I'm going to put that back on top here. 3. Now what we do then is multiply it back down. So 3 times 2 is 6, and then you change the sign and you add straight down. So what do we get? 1. 1 cannot divide by 2. Well, 1/2. So 1 is the remainder. Does everybody see? 1's a remainder. So we know that 2 times 3 is not a factor of 7. So how we would write this is, our remainder is 1. So we have 3. We actually add our remainder. Add 1. But that wouldn't make sense. That's 4. So we have to actually write it a certain way. So we actually have to say plus 1 when we divide it by 2. You guys see how that works? Plus 1 when we divide it by 2. So we have 3 plus 1/2, which is 3.5, right? So it makes sense. Because that is what we know 7 divided by 2 is. Cool! That's how we do polynomial long division. So write this problem down. We go through the same process. It's just longer. Long division always works. You can always take a polynomial and divide it by any other polynomial using long division. So long division is a process that always works. So what we're going to do is set up our divisor, the 2x minus 1 on the outside of our little house. And then what's being divided is inside. I'm leaving myself some room over here because I show my work over here. You should too. You should show your work like I do, because then when I'm grading the test, it's easy for me to find your error and it's quicker for me. So just follow how I show my work, please. There's so many of you. Okay, so this is how you start out long division. You always only divide the leading term. So look, this is the leading term, and we're going to divide it by this leading term. So I'm going to do a little bulletin point. So we do 4x cubed divided by the leading term of 2x. Divide it out. 4 divided by 2 is 2. X cubed divided by x is x squared. And we're done. So that's part of our answer, and that goes back on top here. On top, we're putting our answer right here. Now I line it up just to keep things pretty. So it's a squared. I'm going to line it up with my squared. So 2x squared. There's part of my answer. And we're doing what I call a roundabout process. So we just went around, and now we're going to keep going around. So now we got to take that, and you're going to multiply it back down there and there. So 2x squared divided by, times 2x squared times by 2x. 4x cubed. Now notice, these should be the same. Now 2x squared times by negative 1. Negative 2x squared. Now what we're going to want to do is we're going to want to combine this stuff, but we want our leading term to cancel out. So we've already divided that. In order to cancel out, we need one of them to be opposite. So we're going to take this new thing we just got by multiplying it back down, and we're going to change the sign. Change the sign. Because if you change the sign here, you have to change the sign here. You have to do it evenly. So now that we've changed the sign, which you can't forget to do, that's one of the most missed things, or people don't change it to both, or whatever, however many things, you got to do that. So now add straight down. Our leading term cancels out, which is great. 2x squared plus 2x squared is 4x squared. It's true? Then we have minus 6x, because we can't add that. There's nothing to add that up to. And then we have minus 10. And now guess what? We're back to the bulletin point. We just worked around in a circle doing that same thing over and over until we're done. So let's go off to the side again. I'm going to change color. Bulletin point. You take your leading term divided by the leading term. You always only divide leading terms with long division. 4x squared divided by 2x is 2x. Am I right? So we have up here, going in our circle, plus 2x. Then we're going to multiply the positive 2x back down here and here. So positive 2x times 2x is 4x squared. Positive 2x times negative 1 is negative 2x's. Then you have to have these cancel out. So you got to change the sign, change the sign. Then we're going to add straight down. So those go away. We have negative 4x's. And then we have minus 10. And now we're back to the bulletin point. So leading term, negative 4x. And we're going to divide it by 2x, which is negative 2. So that's part of our answer. Negative 2. Then you're going to multiply that back down. Negative 2 times 2x is negative 4x's. Negative 2 times negative 1 is positive 2. Then we change the sign, add straight down. So we get negative 12. Now look, if we tried to do it again, negative 12 divided by x, 2x, no, it doesn't. Not evenly. So we're done. That's our remainder. That's our remainder. So here's our answer, but we had a remainder. So we have to add the remainder just like I showed you before. In the previous example, the more easy one, we add our remainder. So we're going to say we're subtracting 12, and that's when we were dividing by 2x minus 1. We've got to put that in there, otherwise you're combining those two. Like you'd be able to combine them, which wouldn't make sense. So there's your answer. So now guess what? If I asked you, right, there's your answer. If I asked you, is 2x minus 1 a factor of this, you would say, no, because the remainder is not 0, right, everybody? If it divides evenly, then it's a factor, so we know that 1/2 is definitely not a solution. Just that's how we use it in the future. Yes? No. Valid question, no we can't, because they want us to write it like this, because this is officially what it actually is. But you're right, it does have a remainder. They did let you write it like that in your younger years, though. Okay, let's do another one. Number 5. All my examples are not coming off the homework. So, let's set up our divisor, x minus 4, what we're dividing by. And we're dividing the polynomial x squared minus 3x plus 1 by x minus 4. Leading terms, that's what you divide. So let's go off to the side and make our bulletin point. Leading term x squared divided by leading term x is x. That goes on top. We multiply it back down, there and there. X times x is x squared. X times negative 4 is negative 4x's. Then you'd say I need to change the sign, add straight down. So it looks like we're going to have an x when I combine those, and then we have plus 1. And we're just going around and around and around. So x, leading term divided by x, is 1, which is positive 1, so plus 1. And then multiply it. So 1 times x is x. 1 times negative 4 is negative 4. Change the sign, add straight down. So it looks like we're getting 5. 5 divides by x. Nope, it does not. There's our remainder. So x plus 1 and then plus 5 when we divided by x minus 4. Now, once again, if I asked you, so, based on that answer, is x minus 4 a factor?
No.
Therefore, yep, so therefore, yeah, you're right, because it's 5. So then, therefore, 4 is definitely not a solution. If that's not a factor, then 4 is not a solution to that polynomial. Okay, good. Okay, 6. Do you want another one? How about you do it by yourself, and I'll do it up here, and then you can just check your answer. Okay, so just everyone making sure we're good with this. If you gotta make sure we understand this. If we take the polynomial p of x and we divide it by d of x, and we get some q of x and our remainder is equal to 0, then we know that d of x times by q of x is equal to our p of x. True? And we know that r of x, the remainder, since it's 0, sorry, no, that had nothing to do with it. I didn't mean to say that. And we know that whatever, so let's say d of x is x minus 3, then we know that that's a factor, so then 3 is a solution. Awesome. Okay, so this is how we use synthetic division. Well, let's talk about when we can use synthetic division. This only works if you are dividing by something that is degree 1, a binomial. Binomial means 2 terms, and it has a leading coefficient of positive 1. So the 1, 1, 2 rule. 1, 1, 2 rule. This can be anything, but what you're dividing by has to be 1, 1, 2. So how we set synthetic division up is really interesting. It's way different than long division. So with long division, we write them in exactly as we see them. With synthetic, however, we actually don't use the factor. We actually use the 0, or the solution of that factor. So the solution of this factor is negative 2, true? So we go over here, I'm going to show my work, putting in a negative 2, and we draw a box that's kind of opposite of what our other box looks like and more room. Then what's interesting is with synthetic division, we don't actually use the variables, we just use the coefficients. So 1, 5, negative 1, and negative 9. So you're going to write those in that order. 1, 5, negative 1, negative 9. Now here's one more rule. If you're missing something in here, like let's pretend there was no 5x squared. Let's pretend. You have to put a 0 right here. That's really important to remember. Okay, this is how we do synthetic division. You add straight down, multiply, add straight down, multiply up, add straight down, multiply up, add straight down, multiply up, add straight down, multiply up. So, here we go. So we have a 1, plus we add straight down. So 1 plus nothing is 1. 1 plus nothing is 1. We add straight down, we multiply up. So 1 times negative 2 is negative 2. So I'm going to insert that right here in this next box. Then we add straight down, multiply up. So add straight down. 5 plus negative 2. 3. And multiply up. 3 times negative 2. Then we add straight down. We multiply up. We add straight down. 5. Now everyone, we took a degree 3, x cubed, and we divided by x, which meant we have a now quadratic, x squared, right? So these are just the coefficients. This is 1x squared plus 3x's minus 7, and this will be our remainder. So plus 5 when we divide it by x plus 2. So now we know for a fact that negative 2 is not a solution. That's how we use it in the future. Because the remainder wasn't 0. Yeah, it's way quick. We're going to get way quick. Like, we went grandma slow that time. Let's do another one. Number 16. Yes. It has to be linear. And then not degree 2, but 2 terms. And then a leading coefficient of 1. Oh, I see why you thought that, because I said the 1 and 2 rule. My bad, I'm sorry. 2 terms. That's a valid question. Oh man, this is a bad one to like have as the 1 and 2 rule. No. Well, because they were thinking I was referring to this too. But 2 terms. Okay, so this one we can use synthetic because 1, 1, and 2 terms. So here we go. We use the solution. So we're using positive 5. We're using the 0. Then we put in our box. And then put in your coefficients. 1, negative 5, negative 7, and 25. And making sure that you're not missing anything. Degree 3, degree 2, degree 1, and constant. So we're good. Add straight down. 1 plus nothing is 1. Multiply up. 1 times 5 is 5. Add straight down is 0. 0 times 5 is 0. Add straight down is, and then negative 35, and add straight down we get negative 10. Degree 3 divided by degree 1 is degree 2. So we have 1x squared minus 7, because we have 0 x's, so I'm not going to write that. And then there's our remainder, so minus 10 when we divide it by x minus 5. Therefore we know 5 is definitely not a solution of that polynomial. Okay, let's do 31. Now in the instructions in this section, if you're going to 31, it says divide. It doesn't tell you to use synthetic or long, so just make sure you absolutely can use synthetic if you're going to use it. Degree 1, leading coefficient 1 and 2 terms, we're good, so let's use 1. Put in your box. Now here's why I'm doing this one. This is where people on the test always mess it up. They forget because they're going, and I forget too. We have to remember. If you're missing something, you have to put in a 0. So do you see how there's 0x squareds? Alright, so we have a 1, a 2, then a 0, then a 1, then a negative 3. Add straight down, multiply up, 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 add straight down. That's how quick you'll be at it soon. Now look, you'll say degree 4 divided by degree 1 is degree 3. So this is 1x cubed plus 3x squared plus 3x plus 4. This last thing should always end up to be the remainder. So then plus 1 when you divide it by x minus 1. Therefore, 1 is not a solution to that. Okay, how about you guys try 33? You're getting a piece of homework done. Do it. Try 33 with synthetic division. So hopefully you got this. So because the remainder was 0, we know 1 is a solution to that. It's going to cross at 1 for sure. For a minute. Synthetic division, practice them. Look at 35. It tricks people. They think they can use synthetic division because they use the 1, 1, 2 rule. Be careful because here's why it tricks people. 1, 1, 2. But here's the thing. Actually, it's really not a 1 right here. Here's why. This is not an appropriate way to write this. Remember, there's a better way. So how could we rewrite it? Well, what's the solution? X is equal to -1/3, true?
Yeah.
So remember, we don't write it like this, ever. We would say times by 3, wouldn't we?
Yeah.
And then add 1. So actually, we're really doing this, 3x plus 1. But focus so you can learn how to think. So it says the expression v of x is this, represents the volume of a rectangular safe in cubic feet. The length of the safe is x plus 4. So as I go, I'm going to write down what they tell us. The length we just were told was x plus 4. What are the linear expressions with integer coefficients? Integer means whole number coefficients. So like 1 is a whole number. So it's asking what linear expressions could represent the other dimensions of the safe. So everyone, and then it does tell us the height is larger than the width. So we have a box, and we are finding the volume. Well, we actually know the volume. The volume is equal to length times width times height. Let's put in everything we know. Don't we know the volume is that statement? Look, if you try to factor it, you can't. Why? It's not a quadratic, people. So it's not factorable. So you'd say, okay, well, we got to do this differently. So x cubed minus 13x plus 12 is equal to my length is x plus 4, isn't it? Then I have times my width times my height, which I have no idea what those two things are. Solve for width and height. What would we do? Get them alone. But why? Because we're actually getting them alone. Aren't we dividing both sides by x plus 4? Right? So now you'd say, okay, this divided by this will be our width times our height. Okay, let's do synthetic division, not forgetting to put in a 0 for x squared. 1, 0, negative 13, 12. Add straight down, multiply up. Now guys, your remainder should come out to be 0. They told us that we know for a fact this was the length. So that is a factor, therefore it should have a remainder of 0. And it did. So now didn't we just get that this simplified to be x squared minus 4x plus 3, and that's equal to the width times the height. We simplify this and got this, and that's equal to the width times the height. How am I going to find the width and the height? Factor the quadratic. What multiplies to be 3 and adds up to be negative 4. 1 times 3, negative, negative. Can I quick factor? Yes, because our leading term is 1. So x minus 1 and x minus 3. So now what we have here is this factored to be x plus 4 times x minus 1 times x minus 3, didn't it? So that is factored completely. So my length, we know, is this. The width is, the height is larger than the width, so this would be my height and this would be my width. There they are. It says, what are the other dimensions? The height is x minus 1 and the width is x minus 3. So if I said to you from the beginning, this is on the homework, use synthetic division and the given factor to completely factor the polynomial. So when it's exactly what we just did, right? We were just told, right, in the instructions that we're given a factor. So what do we know for a fact? When we divide it, the remainder will be 0. And then we'll have a quadratic. And then, so your answer on 21 should come out to be x plus 5, that's one of the factors, and then you'll have a quadratic that will factor to be 2 more things. Right? That would be your answer. Just factor it completely. So you would finish that one off. Okay. So, work on a few of those for a second. Keep working on the ones I've assigned already. So what this says is, the remainder theorem provides us a quick way to find the remainder of a polynomial long division problem. So, why would it be useful to know the remainder? So that we know if something's a solution or factor. So this is another quick way to find out what the remainder is. So So here's what the polynomial theorem says. And then I'm going to try to make more sense of it right here. So it says if you divide a polynomial p of x, so like this is p of x, here it is, of degree n greater than 1, meaning this has to be larger than 1, by some x minus a. So I'm dividing by x plus 3. You guys see? Then it says the remainder will be p of a. So the remainder will be p when I plug in a. So a right here. So do you see how this is x minus a, everyone? X minus a. So this must have been x minus negative 3. Do you guys see? So a would have been negative 3. Right? X minus a. If it's plus, then it must have been negative 3. A must have been. Yes or no? Yes. Okay, guys, how does subtraction work? X minus a. If I said, what's a? This is not super hard. What's a? You would say a must be negative 3. How else did it become positive? Okay. Woo! Well, so an easier way to think of it is, aren't they plugging in the 0? Plugging in the 0. So they take, that is true, right there. That's the remainder theorem. You can actually take and plug in the 0 into the function. So look right here. I went through and did long division and I got a remainder of 0. A quick way, another way we could have done, if I would have said, what's the remainder? Instead of going through all of this, you could have said, okay, negative 3 is the 0, right? I'm going to take and insert that in, because that's what the remainder theorem says we can do. So we plug in p of negative 3. So we have negative 3 squared minus 13 times negative 3 minus 48. We get 0. That will be the amount of the remainder. So let's answer some on the homework. 26. It says, use synthetic division and the remainder theorem to find p of a, which finding p of a means find the remainder. Now look at this one, how this one gives it to us. It tells us a equals 2. It didn't put it in a factored form. It gives us the solution, 2. So you're going to use 2. Do you all understand that? So over on this side, since in the instructions it says use synthetic division, and then also the remainder theorem, right here let's do synthetic division. So we put in 2. We put in our coefficients. 3, negative 4, negative 5, and 1. This isn't the remainder theorem, but based on the instructions, it says to do both. Add straight down, we get 3. Multiply up, add straight down. Add straight up, multiply down. Add straight up, multiply down. What the heck did I just say? Sorry, I can't think and talk at the same time. Sorry. So we add straight down, we get negative 1. Isn't that my remainder? So the remainder theorem says we could have also found that remainder by plugging in p of a, which is p of 2. So let's plug in 2. So we have 3 times 2 cubed minus 4 times 2 squared minus 5 times 2 plus 1. That's another way to find the remainder. So you type that into your calculator, everyone, and you will get negative 1. Which way's quicker? This way. So we always use this way. So this is just another way, but we have to show our work. So what's the answer? The answer is not negative 1. The answer is showing your work. So on the test, it's going to be worded like this. You have to show your work. Yeah, if the instructions say that. Yes. To find the remainder, but in all of these we're using it's asking you to divide, but yes, if I did say in the future, yes, that's a good point. So if you didn't want to have to do long division in the future and I just asked you, is this a 0? You could just plug it in. Yes. No, the work is the answer. So you can literally on your homework just write C other paper. But the work is the answer. Let's do one more like that. So use synthetic division and the remainder theorem. So in this one, I get a remainder of 0. So if I plug in negative 3, I should be at 0. Based on the instructions, you would need to do both.